Till now, whatever problems we have solved, in those problems the support was simply supported beam. Now we'll solve the problems for cantilever support. Actually, cantilever support problems are simple compared to simply supported beams. Cantilever beam, in the sense, one end is supported and other end is free, and then the load is applied on the beam. Here in this example, in cantilever beam, since there is only one support, I am going to get only one reaction at this support. But apart from reaction, we will also get a reaction moment at this support. Rest all calculations and the method of drawing SFD and BMD are going to be same. But remember, for cantilever beam, it is always important to consider the calculation to come from that end which is opposite to the support. Okay, always for calculation purpose, come from that end which is opposite to the support. If the support is in the left side, come from right side for calculation. If the support is in the right hand side, then come from left hand side for the calculation. Now if you consider this example, I have to draw SFD and BMD for cantilever beam wherein support is at left end. Okay, so what I'm going to do is I'm going to first calculate the reaction at this support. Actually, at this support there will be a vertical reaction and also a reaction movement. Okay, this reaction movement is not important if you come from opposite end of the support. This reaction movement will become important if you go from the end where support is there. Okay, so that is why if you come from opposite end, the calculation is going to be easy because we are not going to consider this reaction movement. Alright, so first calculation is consider to calculate the reaction force. For that I am going to consider summation of Fy equal to 0. There is only one upward force which I am going to take it as positive. So upward force is positive Ra and rest of the forces are downward. So those will be minus 20 and minus 10 equal to 0. And when I bring this minus to the right hand side, it will become plus 20 because of this, and this will become again plus 20 and this will become plus 10. So adding them, Ra I am going to get it as 50 kilonewton. Now if you want to find the reaction moment at this point, see whatever reaction moment I am getting at this end, it is because of this force and this force. Okay, so how to calculate what is the reaction moment at this section is consider moment due to all the forces. Come from right side, there is a force of 10 kilonewton and it is giving me clockwise movement, so I am going to take it as plus 10 into perpendicular distance is 3.5, so 10 into 3.5. Then this 20 is again giving me clockwise movement with respect to A, so plus 20 into perpendicular distance is 2, so plus 20 into perpendicular distance is 2. Then again plus 20 because it is giving me clockwise movement into perpendicular distance is 1. So when I add them together, I'll get it as 95 kilonewton meter. This 95 kilonewton meter is the summation of moment because of these forces. So it is nothing but applied moment. I'm getting it as plus 95 in the sense because of applied forces I'm getting clockwise movement, but the reaction force will be equal but in opposite direction. So here it will be anti-clockwise direction and the value will be 95 kilonewton meter. If you are coming from this end, no need of calculating the moment. Okay, we can just skip it. Now for drawing SFD and BMD, wherever forces are there, I am drawing the vertical lines. So since there are 4 forces, I am drawing 4 vertical lines, and at each line of force I am considering 2 sections, one at the right and one at the left. Here at the point D also, C and A. Now for plotting SFD, come from right section, consider this section. To this section there is no any force in the right side, so here the value will be 0. Now consider this section, come from right side, there is a force of 10 kilonewton which is acting downward. From right side, if the downward forces is there, we'll take it as positive, so it is plus 10. Now after this section up to this section, there is no any other forces which is introduced, so 10 will move along this line, horizontal line, up to this point. As soon as I move from this section to this section, there is one more force introduced at the right side, that is 20, and it is acting downward, so it is positive 20. Already I was having plus 10, again plus 20 will give me plus 30 kilonewton. Then after this section, if I move to this section, there is no any other forces which is introduced, so same 30 curve is going to be carried out up to this point. As soon as I go from this point to this section, there is one more forces introduced in the right side of this section. Okay, that is 20 in downward direction. So again I need to add it, plus 20. There was plus 30 and plus 20 will give me plus 50 kilonewton. Then from this section to this section there is no any other force, so 50 will continue up to this point. As soon as I move from this section to this section, there is one more force, that is 50, which is acting upward in the sense negative. So from 50, this minus 50 will come back to 0. This is about shear force diagram. It is very simple. Now for plotting bending moment diagram, consider only one section, no need to consider both the section. If I consider this section at this point, there is a force to the right hand side but perpendicular distance is 0, so I am going to consider movement at this point as 0. Now consider this section, come from right side, there are two forces, one is this 10 kilonewton and other is 20 kilonewton. But because of 20 force 20 kilonewton, there is no perpendicular distance, so the effect of this will become 0, because movement is force into perpendicular distance. Since distance is 0, this effect will also become 0. Now consider this force come from right side. This force is trying to bend the beam downward with respect to this section, so it is minus 10 into perpendicular distance is 1.5. Minus 10 into 1.5 will give me minus 15 kilonewton meter. So from here I am joining using a straight line because it is a point load, minus 15 kilonewton meter. Now after this point, if I go to this section, okay, to this section from right side there are three forces, one is 10, 20 and again 20, but this force, the perpendicular distance is 0, so effect of this force will become 0. So only consider effect of this force and this force. Come from right side, this 10 kilonewton is bending the beam downward with respect to this section, so minus 10 into perpendicular distance is 2.5, which will give me minus 25. And this force, if I consider, again this is bending the moment in bending the beam in downward direction, so minus 20 into 1 is minus 20. So minus 20 because of this force and minus 25 because of this moment, so I'll get minus 45. Again I am joining using a straight line because it is a point load. Similarly after this section, if I consider this section, okay, if I consider this section at this point, then what I need to do is I need to come from right side. Okay, now when you are considering cantilever beam, there are two sections, one to the right and one to the left. Don't consider to the left, consider to the right. Okay, when I am considering to the right, consider all the forces in the right. 10 into perpendicular distance is 3.5, so it will become minus 35 because beam is bending downward, minus 35. And this is 20 into 2 is minus 40, and this is 20 into 1 minus 20, so minus 20 minus 40 and minus 35 will give me minus 95 kilonewton meter. At this point I am joining using straight line. Then as soon as I consider left section, this movement will also come into picture. Okay, when I am considering this movement, it is anti-clockwise movement. When I add plus 95 and this minus 95, I'll get 0 value. But remember one thing, that maximum time at this section, at the end section, the bending moment will be 0. For cantilever beam, always the bending moment at this section, maximum time you will get it as 0, because whatever this moment is there, because of I'm getting it because considering all these forces only. So when I consider this summation of moment due to these forces and this reaction moment, they will add up and become 0. So you can see that maximum bending moment is at this section and maximum shear force is also at this section. Okay, now we'll solve one more problem. This will be the last problem for shear force and bending moment diagrams, wherein again I have considered cantilever beam, but there is also a UDL acting on this beam. Okay, the same thing we need to follow. That is, first I need to find what is the reaction force at the cantilever beam. There is a vertical reaction force and also there is a reaction moment. For finding reaction force and reaction moment, I am going to use two static equilibrium equations, summation of Fy equal to 0 and summation of moment about A equal to 0. There is only one upward force, Ra, so I will take it as plus Ra, okay, and remaining force are downward forces which are negative. So here if I consider the remaining forces, look, this is a downward force, that is 25, so I need to write it as minus 25, and there is a UDL of load intensity 10 kilonewton per meter acting on a length 2 meter, so I'll convert it into point load by multiplying 10 with 2, so it will become 20 kilonewton acting exactly at the center. Then there is one more point force of 30, okay, so RA, which is plus because it is acting upward, minus 25 minus 20 minus 30 is equal to 0. If I put it in equation, summation of Fi equal to 0. Then when I take this minus forces to right side of the 0, they will become positive. So I have written here, that is plus 25 plus 20 and plus 30. When I add them, I will get RA as 75 kilonewton. So I got the reaction RA as 75 kilonewton. Then this reaction moment is because of the sum of moment due to force 30 kilonewton, moment due to force 20 kilonewton, and moment due to force 25 kilonewton. Okay, if I get clockwise moment, I'll take positive. If I get anti-clockwise moment, I'll take negative with respect to point A. Come from right side, there is a force of 25 kilonewton. Okay, it is giving me clockwise movement, so plus 25 into perpendicular distances, this is 0.5 plus 2.5 plus 1.5 is 4, and this is 1 meter, it will give me 5. So 25 into 5 because it is clockwise movement, so 25 into 5. Then this force is 20, perpendicular distance here will be 1 plus 1.5 plus 1 is 3.5, so it is plus 20 into 3.5 because it is clockwise movement. Then there is 30 kilonewton force, which is again giving me clockwise movement with respect to A, so plus 30 into 1, I've written it here 30. So finally the moment because of summation of all three forces, I'm going to get it as 225 kilonewton meter. This will be acting clockwise, but reaction will be anti-clockwise. Okay, anti-clockwise, but the value is going to be same, that is 225 kilonewton meter. Now I can go for plotting of SFD and BMD once I calculated the reaction force. Wherever there are forces, I am drawing vertical line. Since there are 5 points where the forces are acting, so I am going to draw 5 vertical lines. Once I draw 5 vertical lines, I need to consider 2 sections, one at the right and one at the left, at all the points where the forces are acting. At this point, at starting point of UDL, at end point of UDL, at point B and point A. Start plotting SFD. Come from right hand side, consider this section, there is no force at the right hand side, so at this section shear force will be 0. Consider this section, come from right side, there is one force 25 kilonewton. At the right side it is acting in downward direction, so it will be plus 25, so I am writing it as plus 25. From this section to this section there is no any additional force, so same 25 kilonewton will continue up to this point. Again, as soon as I go from this section to this section, same force will be there because there is no any other additional forces acting. From this section to this section, when I move, there is a UDL. Okay, because of UDL, when I convert it into point load, 20 kilonewton force is acting, so it is acting in downward, so it will be plus 20. I was having the force of plus 25. When I add this, it will become plus 25 plus 20, which will give me plus 45, but I am going to join using a slanted curve because it is a UDL, and for UDL, for SFD, I am going to join using a straight line. So plus 45 I am getting at both the section, I will get plus 45. Then when I move to this section, again there is no any additional forces in between, so same plus 45 will continue up to this point, this section. When I go to this section, there is one more force which is acting in downward direction, so I am going to add this force. So it will be plus 45, which was already there, plus 30 will give me plus 75. From this section to this section, there is no any additional force, so same 75 kilonewton will move up to this point. But as soon as I go from this section to this section, in the right hand side there is a reaction force which is acting upward, and the value is 75, so I need to take it as minus 75. I was already having plus 75 because of all these forces. Now minus 75 is added, so plus 75 minus 75 will bring back the shear force to 0. This is about shear force diagram. Now to plot bending moment diagram, I need to consider only one section, no need of considering two sections. Come from right side, consider this section. In the right hand side there is one force, but perpendicular distance is 0. So bending moment at this section is 0. Consider any section at this point. If I consider this section for example, come from right side, there is one force 25 kN and perpendicular distance is 0.5, and it is bending the beam downwards, so it will be minus 25 into 0.5 will give me minus 12.5 kN meter, join using a straight line. After this section, again I will move from this section to here. Here again I need to consider any one section. Suppose I consider this section. Okay, when I consider this section, when I come from right side, there is 25 kN force and there is also UDL. Because of 25 kN force with respect to this section, it will bend the beam downwards, so minus 25 into perpendicular distance is 0.5 plus 2, that is 2.5. So minus 25 into 2.5, and there is one more force which is acting downward, and again it is give me negative moment, so plus minus 20 into perpendicular distance is 1. So minus 25 into 2.5 minus 20 into 1 will give me minus 82.5 kN meter. Now since it is UDL, I am going to join using a parabolic curve. Here you can see it is a parabolic curve. Similarly, if I consider this section, okay, come from right side, there are two forces, 25 which will bend the beam downward, so minus 25 into perpendicular distance from this section to this section is 1.5 plus 2, 3.5 plus 0.5 is 4. Okay, so minus 25 into 4, and there is this force also, minus 20 into this is 1 plus 1.5 is 2.5, where I will get the value as minus 50. Okay, once I get after the value at this section, move to this section. Okay, when I go to this section, come from right hand side, there are three forces which are acting, and all three forces are bending the beam in downward direction. Okay, so minus 25 into perpendicular distance is 1 plus 1.5 is 2.5 plus 2 is 4.5 plus 0.5 is 5. So minus 25 into 5 and minus 20 into perpendicular distance is 1 plus 1.5 is 2.5 plus 1 is 3.5, minus 20 into 3.5, and this is minus 30 into 1. I'll get the value as minus 225. After this section, when I move to this section, I'm having already minus 225 kN at this section. When I move to this section, one more bending moment, constant bending moment will be acting at this point. All these forces are bending the beam in downward direction, so I'm taking it as minus. But if you look at this, this is opposite in direction with respect to this, so this will be plus 225. Minus 225 plus 225 will become 0. So this is how I'm going to get bending moment diagram. So this will be end of shear force and bending moment diagram. In next video we will start with the next concept of third unit, that is combined loading.